Today's episode is sponsored by Datadog, the cloud scale monitoring service that provides comprehensive visibility into public cloud, hybrid cloud, multi-cloud environments with over 250 integrations. Datadog unifies your metrics, logs, and distributed request traces into one platform, so you can investigate and troubleshoot issues across every layer of your stack. Use Datadog's rich, customizable dashboards and algorithmic alerts to monitor cloud migrations in real time. To start a free trial today and Datadog sending you a free t-shirt, visit datadoghq.com/cloudcast to get started. That's datadoghq.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. It is good to be back with everybody. We took a week off last week, kind of the 1 week of the year that we take off for vacation, middle of the year, U.S. holiday here. Apologize to those who are living outside the U.S., but our one chance to sort of get away, spend some time with family, get out to the beach, enjoy a little bit of sun. So it's good to be back with everybody. Thank you for putting up with us taking a break last week. I got back from vacation, had a really good time, spent some time with family, and was a little concerned Monday morning. I was like, what am I going to talk about? It feels like it's kind of a slow week. There wasn't much that got announced last week. And, Monday came and went, kind of, again, sort of a slow day. And then boom, somebody got a very itchy acquisition checkbook trigger finger. So it's a very, very busy day here in tech. So as we talk about cloud news of the week, let's talk about some of the acquisitions that went on this week. So first and foremost, I guess the biggest number that's out there, the IBM acquisition of Red Hat finally closed. So this isn't necessarily new news to anybody. The acquisition was announced in the fall of last year. So it's been about a 9-month process here to get through the acquisition. But the IBM acquisition of Red Hat for $34 billion closed today on June 9th. So if you're listening to this, closed a day or so ago. Second one on the list was Cisco bought Acacia, which is an optical networking company, for $2.6 billion. So Massachusetts, Boston area-based company. Thought this one was sort of interesting, decent sized number. Obviously, Cisco continues to look for ways to expand out their infrastructure portfolio. But thought it was sort of interesting, $2.6 billion price tag for an optical networking company. Back when I was at Cisco, they made two really big optical networking purchases. They bought a company called Pirelli Systems, again, for $2 billion, and they bought a company called Cerent for nearly $7 billion. So interesting to see the price points of where optical networking is going these days. That was back in 1999, so 20 years ago. So a little different. Google Cloud made an acquisition. They acquired a company called Elastifile for around $200 million was the price that we heard. Elastifile essentially makes cloud-based NAS offerings. So, allows Google Cloud to now have a cloud-based NAS offering. And the last couple that we're going to talk about today are about Microsoft. So two announcements around Microsoft. First one was Microsoft and ServiceNow announced a strategic partnership. So, they are going to be more tightly integrating the ServiceNow capabilities into Azure. ServiceNow is going to be offering a fully SaaS-based offering that'll run out of the Azure cloud. So that's sort of interesting. So again, tighter integration. ServiceNow obviously growing very, very quickly around being sort of the central enterprise CMDB for companies. And Microsoft, again, trying to take advantage of their long history of being in the enterprise and trying to bring a new offering with ServiceNow. So interesting strategic partnership that got announced. And the last piece of it was, again, about Microsoft. And Microsoft's actually working together with hospital chain Providence to build out a hospital of the future. So they're building some prototype hospitals around the Seattle area, looking at how to infuse technology around hospitals, potentially look at cost of treatments, how they can better partner with that. So again, always try and bring a little bit of business side news to what's going on with the big cloud providers, and what they're doing and trying to get involved deeper in the business side of things as opposed to just providing technology. So very busy day, very busy week so far in terms of acquisitions. It is great to be back with all of you this week. Very excited about our show today. We're going to have a chance to talk with Emil Eifrem, who is the founder and CTO of Neo4j, really the premier graph database company. I know we've been spending some time this year really looking at different types of databases, sort of a fascination of ours. And there are so many cloud options out there for databases. We thought it'd be interesting to dive into Neo4j, and we're excited to talk to Emil in our interview coming up. So with that, that's our Cloud News of the Week. Thank you all for listening, and let's get to the interview. Today's show is sponsored by DigitalOcean. DigitalOcean offers the simplest, most developer-friendly cloud platform. It's optimized to make managing and scaling apps easy with an intuitive API, multiple storage options, integrated firewalls and load balancers, a new managed Kubernetes service, and much more. From predictable pricing to flexible configurations to world-class customer support, you'll get access to all the infrastructure services you need to grow your business. Plus, DigitalOcean's community provides over 2,000 tutorials to help you stay up to date on the latest open source software, languages, and frameworks. So to get started on DigitalOcean for free, with a free $50 credit, go to do.co/cloudcast. That's do.co/cloudcast. And we're back. Aaron, it is good to have you back on the show again, man. How you been?
I've been great. Hope everyone has been well.
You know, one of the things that I've kind of obsess over on the show, because I don't necessarily understand the space terribly well, but I try and cover it as much as possible, is databases. And I know if you've been listening to the show for a while, we've covered a lot of different database technologies. So cloud databases, time series, NoSQL, and so forth. And one of the ones that keeps popping up in the things I've been reading about is graph databases. So I thought today would be kind of cool if we're going to go talk about graph databases. We may as well go talk to the leading graph database company, and we may as well talk to their founder, who's been working on this for a very, very long time. So excited to have Emil Eifrem. Emil, welcome to the show. Glad to have you with us today.
Thanks. Fantastic to be here.
You know, a lot of times we will talk to people who are sort of starting new companies. You've been doing Neo4j for over a decade now. So before we dive into that, give us a sense, having been around kind of the data side of the industry for over a decade, like how has what people do with data changed over the last decade? It used to be very relational, but now, it's everywhere. It's in our devices. It's kind of a constant thing for us. So give us just a broader scope of what the last number of years has done in terms of data change in the industry.
Oh, yeah, that's a great question. So I guess, we could easily do just a single episode, actually multiple episodes just on that question alone, probably. But maybe let me answer that through maybe two different lenses. One is kind of the fundamental nature of data, right? Which I do feel like something has changed, something has tipped over the past, let's say 10-ish or maybe 15-ish years. As you alluded to, obviously, the relational database has been the dominant paradigm since, let's say, the 80s, right? It was really brought to market, like RSI, which ended up becoming Oracle, was founded in 1979, right? But it's really in the 80s that it came to the market. And then it's been the dominant force in data management since then, basically, right? And then up until probably early 2000s is when we started seeing some of the early skirmishes of this, when the big web companies, after a while, they started saying that, hey, you know what? We really like the relational database, and that's kind of our default choice, but we were forced to abandon it because operating at our scale, the relational database just couldn't cope, right? So we had to invent our own. And, we are Amazon, and we're calling that one Dynamo, and here's the academic paper describing what it looks like. Or, hey, we're Google, we call ours Big Table, and here's the academic paper that outlines how it works, right? And so that was the first time when we started seeing that, hey, you know what? Like this whole, one-size-fits-all paradigm, maybe some things are starting to change. And of course, that got a name. You mentioned it, right? In the latter part of the 2000s. I think it's exactly a year ago. It was in June 2009, I believe, maybe in July, that there was this famous, maybe infamous article about the NoSQL movement, right? It's almost to the day 10 years ago now, when people started realizing that, hey, maybe I shouldn't just use the relational database for everything. And I think fundamentally what has changed here is two axes. We have a huge increase in volume, and this is what gets all the press and all the buzz, right? The fact that there's so much more data generated today than all the previous years combined, and I'm sure we've all read articles like that, right? So that's kind of one axis. The other axis, I think, is probably less talked about or less well understood, but it's, I think, equally impactful, which is just an increasing complexity of data. And I think those two things in combination is what led to this explosion of alternative databases, where we have more specialized, more narrow data domains, right? Data models. We have time series databases, we have key value stores, we have document databases. And then, of course, my corner of the world, which is focused around how data is related, around connected data, and that is the world of graph databases.
So help me out with that a little bit more then. With all these new patterns kind of emerging, I'm going to kind of flip it on its head and kind of go to the business side for just a little bit here. You've got business reasons, you've got technical reasons, which we just kind of talked about a little bit there. But this choice of database platform, I completely admit up until a few years ago, I was like, okay, is it a SQL database or is it a NoSQL database? Right. I felt like it was a very binary decision at times. But you kind of mentioned this, like how do you fit in the business level thoughts of all of this, of choosing the platform, and what are some of the like decision points? And then, maybe go into the technical aspects a little bit once you've defined the business points.
Yeah, okay, that's great. I mean, I guess I'd look at it maybe through three lenses, actually. What I just talked about was the data lens, which is kind of the fundamental nature of data and how that has changed, or at least how we record data has changed over the past 10 years. So that's kind of one lens. I think the second lens is actually a trend in application architectures, which I believe is a huge driver, or maybe possibly the way to look at it as a huge enabler for all this, right? Where I think we've seen this increase in, let's call it, modularity of architectures, right? Which it started out in the late 90s, early 2000s. I don't know. The demographic of our listeners, but some of us are gray-haired enough to remember SOA, right? Service-oriented architectures, and WS Star, like the entire web services stack, which was this horrible piece of crap, to be honest, right? But at least the goal was to try to modularize architectures, right? And we've seen that, of course, evolve a lot. That entire broad trend over the past decade or so, where we have, let's say, on the development time of things, we have microservices, right? And then maybe on the runtime side of things, we have the entire container, trend, right? And I think what that means is that all of a sudden we've taken our big monolithic applications and we've chopped them up into pieces, sometimes too many pieces, and that leads to its own set of problems, which we can talk about if you want to. But you chop them up into some set number of pieces, and then all of a sudden you have a little smaller scope of your application, and that smaller scope can handle a different shape of data. And all of a sudden, you have the flexibility for that shape of data to choose the most optimal backend, right? So maybe your microservices is all about handing, a payroll view of the customer, or not of the customer, of the employee, probably, right? And it turns out that a payroll, like if you ask any layperson to draw a payroll, right, on a whiteboard, they're going to end up drawing a table. I think that's a very natural shape of data for payroll. You have first name, last name, title, salary, maybe a hire date or something like that. And that's it, right? Extremely tabular data, right? But then you start looking at, hey, maybe you have a recommendation engine microservice. And that one is working with data that is much more connected, much more pattern oriented. It's about taking the entire product hierarchy, and it's about matching that up with customer purchase behavior. Right, and that if you ask someone to whiteboard that, who's not plagued with third normal form and OR, and things like that, and you're just a layperson, they will not draw a table, not at all. That's not what that data looks like. That data is actually a network or a graph, and then for that microservice, you're then free to choose a graph database. Right, and so that entire trend in application architecture, I think, would be the second lens that I would look at this. And then thirdly, to get to your what you actually asked about, which was the business side of things. So, like I've felt that the business side actually have had very little influence on how to choose data platforms in the past. Right, ultimately, the business wants to solve a problem. They have a supply chain problem or something like that. And if they don't care what are us geeks, what kind of, technology platforms we choose is up to us. And, quite possibly the CIO might have, opinions, right? Because they want to standardize on stacks and things like that. But broadly speaking, my experience has been, at least inside of the enterprise, like there's been very little in the past influenced by the business side. I feel like that has changed in the past at most 5 years, because basically the advent of AI and machine learning, right? And this increasing understanding that, even all the way up to the CEO of a Fortune 500, they understand that they're going to have to be a tech CEO, or they will be replaced by one, either replaced running that company, right? Or their entire company will disappear and be replaced by a tech company, right? And I think probably the poster child for all this is the most recent trend of automation, which of course is AI and machine learning. And I feel like that is driving a lot of decisions, or at least influencing a lot of decisions, all the way down into the specific technology stack. And we certainly see that a lot at Neo4j.
When I look at kind of the set of customers that are using Neo4j, it's pretty broad. It's everything from financial services to retail to military applications and so forth. Do you find, you talked about the shape of data, we talked about connectedness and AI, like, are there certain types of use cases or certain applications that are, immediate kind of common uses of graph databases versus other NoSQL databases? Or is it just gotten to a point where, like you said, there is so much connectedness of data that it can be applied to lots of different things?
Yeah, we actually see both. And the precise answer is one of time zone. Actually, sorry, not time zone, but time horizon. I got confused there because I'm constantly living in multiple different time zones. as we're recording this, I'm in Europe, but I'm in California all the time. So I think my actual time zone is Iceland or something like that. But no, it's an answer of time horizon. So today, we see a lot of early adopter use cases. Probably 2/3, between 60 and 70% of our deployments today, at least on the enterprise side, I focus on that, is around top 6 use cases, right? So these are recommendation engines, right? Other people bought this, also bought that. Fraud detection, for example, right? So it turns out with normal fraud detection systems, you can capture, basically they find anomalies. You look at all your transactions, maybe along something like, dollars per transaction and number of transactions per account or something like that. And you chart that all out. And then you look at, hey, this is all within the band of what's normal. Anything that's outside of that is an anomaly, and I'm going to investigate it. What that won't be able to capture is that if you have a lot of transactions that in and of themselves are within that band of what's normal, they're not anomalies, but they're connected in ways that are fraudulent. For example, fraud rings. In order to be able to do that, you have to be able to operate on connected data, which is obviously our sweet spot. So that's the two of the top 6 use cases. And I won't go into details with the others, but it's things like master data management, customer 360, identity and access management, things like that, which is where we see a lot of like prevalence of connected data combined with very direct connection to business value. Right. Now, as you allude to, like over time, everywhere where you have software, at least everywhere you want to operate on data, we believe you're going to use a graph database in the future.
Now, so let me ask you this, because Emil, when I'm thinking about everything you just said, I kind of have gone to this general trend in the industry of, okay, as we decouple more things and as we get, a lot more of breaking things down into more microservices, there's a trend, or the pendulum kind of swings the other way of like, okay, now we have a lot of complexity. Now with that complexity, you have a lot of interdependence and a lot of overhead of managing all of these systems. And so it's almost, at times, and again, when I say in our industry, like over the last 20, 30 years, we've gone from extremely monolithic architectures to extremely decoupled architectures. There's great power in all of that, but there's great responsibility in all of that and great complexity in all of that. What are some of the most common challenges that you've seen in the decoupling of these services or this evolution towards it?
Yeah, there's a lot there, actually. And again, probably worthy of just a single episode focused on just that. But if I have to call out one, it's the one that I mentioned earlier, which is we've just seen people, go too far on the other end of the pendulum, right? Which is, okay, so having exactly one huge monolithic application that serves all your needs with this super locked in vertical stack, is not the answer most of the time, right? But the flip side, where you have thousands or tens of thousands of microservices, is just completely unmanageable too, right? And at some point you could end up where a little bit similar to like EJBs in the enterprise Java beans in the early days, where you, like, for every single object, you had this massive amount of overhead around it, right? Like you had to create, tens or, maybe 15 to 20 different classes and files just around every single object. You can definitely go to that end of the extreme too with breaking up your architectures, and we sometimes see that, right? Now, I'm Swedish by origin. There's a great Swedish expression or Swedish word that I don't think there's a translation for in English, but it's the word lagom, and lagom means just right, like not too far on that side and not too far on that side. And I guess what I would love to see in the world of microservices and containers is a little bit more lagom approach to it.
I want to shift gears a little bit, kind of away from the technology and just towards a topic that's been coming up a lot is, so Neo4j has been open source. You guys have been very active in contributing around open source and open source communities. Lots of changes going on as companies try to figure out what the right balance is between active open source communities, commercial software, and like delivering software that people run, and then delivering software that is a cloud offering. How have you guys thought about that balance, or what have your customers asked for in terms of what's free, what they can run, what they may want you to host as a cloud service? Like how have you kind of tried to balance all of that, especially as the cloud services become more commonplace how people are using software and technology?
Yeah, it's a great question, and obviously one that as a founder CEO of an open source company, like, I spent a lot of time thinking about this, and there's also a lot of discussion in the broader community about this now, right? Obviously, the past year or so, in particular because of how some of the cloud platforms, specifically Amazon, right, how they've interacted with a lot of open source vendors that have created a lot of stir, right? So my broadest philosophical view of this is that I think that open source monetization is a tricky subject, but it's all about, like, my guiding principle is that you want to segment out the market between the people who are more time than money, from the people who have more money than time, right? Because I believe that in open source software, and probably even in software generally speaking, like, the people who have more time than money, they're not going to pay for your software. And I actually don't think they're going to pay for your software if you're Microsoft. It doesn't matter if you're open source. Like, if you have time, you can always get any software for free, I believe, right? So don't even try to monetize that, right? But you want to segment them out from the people who have more money than time, right? So these are typically the big corporations of the world, right? Where, for example, for us, we've chosen to put Neo4j Community, which is our open source edition, is completely fully featured, right? You have everything that you want as a single developer. But if you are a big enterprise and you're writing an application that is mission critical, then you know what? Like, you want your database to be clustered, right? You want that to run across multiple machines, so that if one machine fails, then your application is still up and running. That's an enterprise-only feature, right? Or if you want to integrate with Oracle, for example, well, our kind of view there is that, hey, if you can afford to pay for Oracle, you can afford to pay for Neo4j, right? And so we put those kind of features in the enterprise edition.
Yeah, makes sense. Makes sense. And like you said, it is a tricky thing, and there is kind of no one answer to it. So yeah, it's good to kind of get your perspective on that.
I also
let me just ask you this too. It's kind of a bit of a follow-on of that. Folks that are kind of interested in this space specifically, how do they get started?
Oh, do you mean get started with graph databases?
Yes, correct.
Yeah, it's actually very, very easy these days, right? So first off, you need to choose your graph database, and I shall mention that up front, that there's multiple graph databases out there now. But Neo4j is, I believe, I'm obviously quite biased in this, is a pretty good graph database. So if you want to try out Neo4j, you go to neo4j.com. There's a very, very easy Neo4j desktop download that you can download and run locally on your machine, right? Which is, I think, a pretty solid curated experience where you get a couple of examples. You have an IDE or a way of interacting with the database that includes an examples, query sets and data sets and things like that. If you don't want to even download or running anything locally, there are cloud-based instances that you can run. They're called Neo4j Sandbox, which come pre-populated. I think there's, a dozen or so data sets out there, including things like the Panama Papers, who you might recall from a few years ago was one of the biggest news stories of, I think, 2016, which mapped out a lot of tax fraud amongst the wealthy and the influential. And some of those data sets, so those journalists all use Neo4j. So they're available over there, but also, let's say popular commercial applications like recommendation engine data sets and fraud detection data sets, things like that are just available at the click in your browser.
Yeah, so people, if you want to do a money laundering hackathon, use the Panama Papers, grab Neo4j, you're good to go.
Yeah, one of the things that I usually do at conferences is that if I go to Austin, Texas, I pick out whatever zip code is closest, and then I run a live demo where I just type in, I just run a Cypher query. Cypher is our query language with that zip code to see if there are any people that are in the Panama Papers locally, actually, from where the conference is. That one is always interesting to look at.
Yeah,
well done.
Great.
So,
go ahead,
Emil. We're kind of running out of time here. Where can everyone find out more about you and either catch you on either side of the world or to go learn more about Neo4j?
Yeah, so neo4j.com is always a good way to start. And there's a wealth of information over there. And then obviously the Neo4j Twitter handle at Neo4j. My name is Emil Eifrem. I'm at EMIL EIFREM, Emil Eifrem on Twitter.
And Emil, one last thing. So completely for the audience here, little bit of a cultural experience here. For those in the States that are looking for a new holiday, Emil, what are you doing for Midsummer?
Well, so Midsummer, so this will be interesting. I found, after having lived in the US for 8 years, that it's impossible to factually describe what we do at Midsummers and get people to understand that I'm not joking. Like, if I just factually describe what we're doing, people literally believe it is a joke.
To poorly explain the inside joke. So I have a very good friend who is Swedish, and I have been going to in Sweden. They celebrate a holiday called Midsummer, and it is exactly what you think it is. It's Midsummer, but at least here in the States, we celebrate it by, quite frankly, getting together and drinking pretty heavily, usually with shots of vodka, which probably isn't the proper way to do it, but it's the way we've Americanized it.
No, that's definitely part of it too. But then we dance around a maypole like frogs. We have a frog dance that we dance around the maypole. And, all the girls are supposed to go out and get 7 different types of flowers that they then put beneath their pillow so that they dream about the man they're going to marry. And there's all kinds of stuff like that going on. But 80% of it, I have to admit, is about the vodka.
Yeah, and that is coming up this Thursday, if I remember correctly.
Friday, yes,
Friday. So just so everyone knows, by the time this is published, happy Midsummer, everyone. And there you go. There's a new holiday for everyone that needs an excuse to drink this weekend.
Very, very cool. We are learning lots about technology and culture on this show. We're trying to bring a little bit of everything for you folks. So with that, we're going to wrap it up. For Aaron and for Emil, we very much thank you for your time, for everybody. Thanks for telling a friend about the show. Thanks for listening to the show. Thanks for rating it on iTunes. Big thanks to both DigitalOcean and Datadog for sponsoring today's show. And with that, we're going to wrap it up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.